Hello, this is Group 1 Engineering presenting our cardboard canoe competition presentation. The engineers for the project were Balvo, Deanna Patel, Jean-Marc, Thomas Tove, and Javier Garcia. Today, we're going to be going over introduction, our problem statement, agenda and outline, technical details and analysis, visual details, summary, and conclusion.
For this project, our group wants to enhance our cardboard canoe with the standard of a high-performing sports car. Today, we will introduce the version 1 speeder. One of the main aesthetic flair of a sports car is its balancing spoiler, in which we will add to our canoe, alongside with aerodynamic surface to help it sail better in water. Our main motivation, as stated in our motto, is when given a promise, we over-deliver. Another important value that Group 1 believe in is to remain environmentally friendly, so most of our cardboard used in this project was dumpster dive for.
To complete this project, we use our knowledge of engineering economics in the construction of the canoe in order to make it cost effective. Also, our goal is to develop a team spirit while competing against each other by working with team members. Our problem approach was to inquire skills such as listening, learning, assembling, verifying, and designing, then using those skills to give the final approval.
It was not hard finding motivation for this project, as all the engineers working together are all self-motivated no matter what the task is. Of course, not only winning, but getting first place for the competition is one of our goals. Lots of sponsors have got together to make this event as special as it could be, and we're looking forward to putting our best design out possible. The learning experience obtained for this project involves the communication with other group members and the scheduling to ensure the project and deliverables get done in time. The handling of critical situations was also dealt with in this project when one of our tests did not go as planned and the boat took on some water damage. But with communication and planning with other teammates, we were able to correct the situation and avoid major failure.
On the technical details and analysis, we decided to reinforce cardboard structures and roller beams to prevent sideways buckling and rupture from the tension of the bottom of the canoe when water impacts the canoes as the image shows. Also, on the front and the back of the canoe, we have a pentagon design. The reason being from the front side will be elevated just a little bit to ensure water does not enter the canoe while blocking the water because of its geometry.
For our visual detail, as you can see right here, this is our original plan and drawing for the canoe, but we later changed it to varies with the size and the height of the cardboard. This is one of the first, this is the beginning of our building of the cardboard canoe. We lay 2 pieces of cardboard on the bottom, and then we slowly layering them up and alongside with the side piece of the canoe. This is our original truss system, which we test, and it used when one of our group mates sat on it, and this is the cross-sectional area of that truss system, so we can see how it failed and how to improve it. To prevent water from getting into our canoe, we excessively taped the bottom, but later on it took on damage, so we have to go back and retape it and make sure that every cracks of the cardboard is covered by tape, so no more water would seep in.
So as the summary, we emphasized on the overall safety and well-being of all of our teammates. We made sure that we were communicating effectively, and we also kept in mind the budget of our project. So it wasn't very expensive because of the cardboard that we got for cheap, and also for the rolls that we got at cheaper costs. And we made sure that we were conservative on being the rolls, given the requirements that we were supposed to follow. For the analysis and details, as my team members have mentioned before, we made sure that the design is pentagonal and it's sharp at the edges so that the water does not directly come in from the frontal side. And application of technical knowledge, we used skills from the fluids mechanics class, which is buoyancy, then compression, tensile forces, and we made sure that we were applying all those skills. Conclusion, we made sure that we were using adequate tape. We used the sharp ends, which would allow us for fast pedaling without frontal obstruction. And we also made sure that we were meeting the requirements in terms of the width and the height to avoid entering of the water into the canoe. And this is a wrap up of our presentation. Thank you so much.